Hello everybody, I hope you're all doing well and you're ready for question 13 on our grade 7 Gauss contest. On the spinner shown, PQ passes through the center O, that makes it a diameter. If the areas labeled R and S are equal, what percentage of the time will a spin stop? Yes, it's a spinner shown. I don't have a little, I'll add a little spinner of my own. What percentage of the time will a spin stop on the shaded region? So how are we going to work this out? Well, you find percentages by taking fractions out of a whole and multiplying them by 100%. So what fraction is this shaded area out of the whole circle? Because that's the whole area the spinner could land on. Okay? Well, how can we work this out? Well, the area of a section of the circle, or I believe they're specifically called sectors, is tied to its angle. And you'll notice they did give us a nice little right angle. Now, PQ is a diameter, which means we've got 180 degrees here. Telling me we've got a right angle here means that we must have 90 here. And that leaves a 90 degrees left here. But that's being split up into R and S. Now, because they tell me R and S are the same size, we must have split the angle evenly as well. So it's 45 degrees and 45 degrees. Okay? So the area, or the fraction of the total circle area that the shaded region is the same as the fraction of the total angle, 360 degrees, that this 45 creating R is. Okay? And you can find that that's 1/8. So R is going to be 1/8 the whole area, and we just need to figure out what percentage is that. Okay? And you can grab your calculator or you can divide manually. You'll find it's 12.5%. So 12.5% of the time when I spin a spinner, it'll land in this shaded area. Okay? 12.5, that's an answer of E. Okay? Now, this wasn't the only way to do the question. Of course, you could say, all right, the full circle is 100 degrees. PQ splits it in half, so now 50% of the time will land on this portion. 90 degrees splits this in half again, so now we're down to 25% of the time will be up in this top portion. And then R and S split the remaining space evenly, so half of that time, so half of 25%, 12% will be in the shaded region R. That's another way to see E. Okay, this one's a bit more computational. This one is sort of reasoning your way through the problem, and both are good approaches to be comfortable with. Okay, so that's question number 13. Up next, you guessed it, question 14. Until then, take care and have a wonderful day.